specific questions about book problems so far? Were they super mysterious? Okay, so we're talking about Chapter 9 homework. I will show the setup real fast for the first few. Okay, and then it looks like many people have some work to do just for that. Right, Shannon? Phone away, please. Or you can rocket through this and help me out then. Okay, so make sure we don't need to know the mass of the car. The person is 75 kilograms. We start at 20 meters per second. Yep, and it hits a bridge abutment. Yikes. They should have used a crash test dummy. Dramatic. Calculate the average force on the person. Okay. The average force. Remember we used to put a bar over that? You can do AVG for average. We're going to calculate the average force. You displace forward. Is it 1? The dashboard compresses an average of 1 centimeter. Okay, and versus an airbag that compresses 15 centimeters. Okay, if you're using the average force, that's the same thing as doing a constant force. Okay, let's see. Whoop, constant force, constant acceleration. Okay, so you could use change in energy. Let's see. Change in kinetic energy, you have mass mv squared, and that equals the work, which is your force times delta x. So the work that it does, you take your change in kinetic energy and divide by the displacement, and that will be your average force. And V final equals 0 because it stops. You could also, since you have a constant force, your average force times your velocity. Oh no, that's power. I could get change in momentum. This is just easier to do with energy. Energy is great. But we can do... Okay, if we can find our acceleration, then we actually know our time. Try it this way. The force is the change in momentum over change in time. And if you calculate your acceleration, then your time is your change in velocity, which is just 20 minus 0 over the acceleration. Okay, so if you're kind of salting it backwards, you could do mv0 divided by it ends up just being a. It's delta v times a. Okay. Energy's the best. Let's see. 31. Momentum as a function of time. Okay, net force is derivative of momentum. Take the time derivative. 32, same thing. Calculate area. right? That's why I'm on about this. Mm, you really can just multiply, calculate areas. If they give you the force versus time, like on 32, the change of momentum is just that easy. The area between the graph and the horizontal axis, 32, 35, and the train's momentum is conserved. Okay, so those hints should get you up to 36. And we should jump over to free response. I'm not so sure. Are we feeling brave and awake and we want to do 36 with 2 dimensions? I think we should save that for a little bit. Okay. Any other questions up to 36? Maybe we'll come back to it. No? Okay. Let's examine the rocket next. I'll move my page. Since you're already done, how did you calculate the magnitude of the net impulse? Fantastic. I'll call on people who look finished. Let me cut my video.